So let's talk about the types of data we can collect. So from a sample, depending upon what that sample is, if it's people, plants, businesses, right, we can collect many, many different types of data. So let's say for right now we're studying people. Here are some different types of data we can collect. We could get eyes. We could get eye color. We could get age, race, height, weight. It depends what you're trying to study, right? We could ask for education level, income level, whether or not you're a first generation person, so your parents were immigrants, things like that. So when we're studying students, depending on what you want to learn about the students, like if you were interested in learning about their study skills, right, and how that affected their GPA, you'd want to collect data on their grade point average, maybe their major, that could affect how much they're studying, maybe their favorite place to study, maybe how long they study, do they listen to music when they study, do they not listen to music when they study, so you kind of can pick and choose what information you need to know, right? If you're studying students' study habits, their eye color or their height or weight probably has nothing to do with it. So although that's information you could collect, it's kind of unnecessary. And hint, hint, people are more likely to fill out a survey if it's not 15 miles long. So make sure your questions are concise if you were to create a survey and really benefit your study. So what do we do with the data? We can calculate a statistic, right? This is a number that represents a property of a sample. I know I've said this like 5 times already and we're only like day 1 into the class, but it's important, right? This is one thing to take away. We can calculate a sample statistic to estimate a population parameter. So when we're studying our student sample, we could calculate the average height, the mean height, the GPA, your most popular favorite subject, right? These statistics from our sample give us information about a population parameter. So when we're studying a sample, what we're really doing is we're studying the variables. Our variables, if you remember from my college algebra course, which I think most of you took, are usually labeled X or Y, right? And it's a characteristic that can be determined for each member of the population. Every single member of your population needs to meet this criteria. So if we're studying some variables of college students, we could ask age, eye color. Are there any possible other variables that you can think of? Well, there's like millions, right? That we could come up with, such as major, favorite subject, ooh, the amount of FAFSA that they qualified for, that could be interesting. All those things. So there are 2 different types of data. Well, kind of. So our data will break up into 2 categories. Our data is either going to be numerical or categorical. Numerical data, think of like number, right? The value of any variable that takes on a number is going to be numerical. Otherwise, it's categorical. Categorical data breaks up into categories. For example, eye color, class standing, such as sophomore, senior, junior. I did that out of order. It breaks it up into categories, right? It doesn't have a numerical value to it. And it's important to know whether a piece of data is numerical or categorical, because we're going to use that fact to display our data in different ways when it comes to graphing and visual displays of data. A margin of error in a statistical study, and we're going to learn how to calculate the margin of error later on in this course, like way later, like chapter 8. The margin of error is used to describe the range of values or confidence interval likely to contain our population parameter, right? So our margin of error is usually defined to give us a 95% confidence interval. That means I'm 95% positive that the true population parameter lies within this interval, right? So what we would do is we take a sample statistic and we add or subtract, we subtract and we add our margin of error to give us this interval. Now, you've probably seen this before. Why? Because we just had an election, which I'm happy about. And in the election, right, you probably heard stuff like, oh, we've got, he's polling at 46%. Oh, I'm writing under myself. I don't think you can see it. Okay, he's polling at 46% within 4 percentage points, right? We've got like a 46% approval rating within 4 percentage points. Well, what does that mean? Well, that is our margin of error. So in order to figure out where the true population parameter would be for, let's say we're looking at approval rating, we would take 46 minus 4 and 46 plus 4. That would give us an interval of 42% to 50%. So the true approval rating of whoever this guy is between 42 and 50%. So the Pew Research Center for People in the Press, this is a real organization, interviewed 1,002 adults, which is a weird number, not a nice even number, but good for them, and asked them to give a reason for the recent increase in scandals among elected officials. Very scandalous. So about 50% of the respondents claimed that the increase was due to greater scrutiny by the media. The margin of error for the poll was 3 percentage points. So what can we conclude about the percentage of the population that believes the increase in political scandals is due to greater media scrutiny? Scrutiny. Okay, so we're going to take 57% minus 3 and 57 plus 3. That would give us a range of 54% to 60%. And I could say that I am 95% confident that the true population parameter is between 54% and 60%. And now you all have seen why I teach from PowerPoint, because my handwriting is kind of abysmal. So that's how we'd interpret our confidence interval. Reset, get a glass of water. So what are the basic steps in a statistical study? So the first thing, you need to know what the goal of your study is exactly, right? That's going to help you determine what population it is you want to study and what you want to know about them. Next, you need to choose a representative sample from the population, which is what we're going to go over in the next section. Once you've got that representative sample, you're going to collect raw data from your sample, and you can summarize these data into sample statistics. As long as your sample is representative, you can use those sample statistics to make inferences about your population. Next, you want to draw some conclusions based on your study and determine what you learned and whether you achieved your goal. Now, even if you didn't achieve your goal, right, or maybe your hypothesis, which we're going to talk about in chapter 9, was wrong, it still is important and it still adds information to the field. So that's really a good thing.